asymptotes and holes and all kinds of stuff like that. This is one of those that I have to admit, this is a weakness of mine. Graphing has never been a strength of mine as far as math is concerned. Probably for the same reason that it's probably not a strength of yours, because when I was taught to do all this stuff, the graphing was not a focus. So I want to make it a focus. I think it's important for us to understand the graphs. It's easier for us to see what's going on in the equation if we can see a graph. So let's go ahead and move forward. Now, we're going to go through this relatively slowly, okay? I think it's important that we go through this slowly, especially because this is not an easy concept. So, rational expressions. So we need to talk about first domains and ranges. Now, domain we know is the set of all the x values that are possible for a graph, and the range is the set of y values for a graph. So when we talk about rational functions, the domain of a rational function is the set of all real numbers that are not zeros of the denominator. So those can be asymptotes, all right? They can be asymptotes, or they can be holes. So you can literally have a graph with one spot not graphed. So let's look at this here. So we're going to find the domain of a function. Now, to find the domain of a function, we have to find the zeros of the denominator. Now, usually that's just a matter of solving. Sometimes those are complex equations. They could be cubes or fourths. I don't remember what's in your assignment for sure, but we're going to stick with squareds in the examples. All right. So to find zeros, if you remember with a quadratic function, okay, I factor the quadratic function, and then I set each piece equal to 0. Now, whatever those values end up as, my domain for my rational function is all real numbers except the values that are my zeros in my denominator. So in this case, it's -1/2 and 3. Okay. Now, before you start saying, Miss, what if I can cancel with the numerator? I do not want you doing that yet. There are situations where we can do that, but it's still a 0. It's still going to be, it's still not going to be in the domain, even if I could cancel it. So, all right, so here's your practice problems, okay? One is a real simple one. I hope you can figure that one out. And B, you would have to solve for the zeros. Okay, and here are your solutions. Okay, let me move this. That's kind of obnoxious. There we go. All right. Okay, so let's talk about asymptotes. Okay, so if we have an asymptote and a vertical asymptote at x equals c, meaning that if I were to graph the line, it would be like x equals 2. That's the vertical line. It has to be, c has to be a 0 of the denominator and not a 0 of the numerator. Those are two really important skills. So what you have to do is you have to find the zeros of both. Is this a lot of work? Yes, it's a lot of work, okay? There's a reason that a lot of teachers skip this kind of stuff, because it's a lot of work. It's not necessarily difficult, but it's a lot of work to get a graph. So, and yes, you could do this in your graphing calculator, but that's not what I want. I want the algebra side of this, all right? So, so I would find the zeros of the numerator. Now, the zero of the numerator would be -1. Now, this doesn't mean anything for my domain or anything. It's just going to tell me for sure if I have an asymptote, a vertical asymptote at that. Now, when I find the zeros of this function, I get 2. So I subtracted 4 divided by 2. So 2 is different than -1. Since -1 is not a 0 of the denominator, it is a vertical asymptote. If they were the same, you would have a hole. So it would be like a graph like this, and then there would be that one number would not be graphed, and then the rest of it would. Okay, so if they're the same, if you have the same 0 on the numerator and the denominator, you will have a hole. If they are different, you will have a vertical asymptote. Okay, and we talked about that already. Okay, so let's look at this. Now, I want you to, now this one was kind of complex, so I had an x in each of them, so I could factor out an x to start with. And then I had to use the quadratic equation because this isn't factorable. My numerator, I went ahead and solved. So my numerator has a 5, so that's only going to help. That's only going to be beneficial if either one of these end up as a 5. So I have x equals 0 as an asymptote, and then I also have this line here. So this is actually 2. So this has 3 vertical asymptotes. I want you to realize that, because this is -7 plus square root of 41 over 2 and -7 minus 41 over 2. So if I were graphing this, I would have 3 vertical asymptotes all at those places. Since none of them are 5, there's no holes, it's only vertical asymptotes. So always need to check and see which one is which. And that's it. There's no practice problem for that one. So I will see you tomorrow, and we will practice in class.